Hi guys, welcome back to another video from the Algebra Bros. In the previous video, we've seen how to compute some basic operations on vectors, and today we're going to see what collinear vectors are and how to determine whether a vector is collinear or not with another. But now let's hop into it. First, let's define what collinear vectors are. So, two vectors are said to be collinear if they have the same direction. In other words, they are collinear if and only if the lines representing their direction are parallel to each other. I've displayed here three common examples. So in the first case, the two vectors are clearly collinear and of the same sense, in which we can see that they are of the same direction. Then for the second case, they are both collinear, but in this case in opposite sense. And in the third and last case, we can clearly see that the two vectors are not collinear. Indeed, they clearly don't have the same direction. But how to find whether two vectors are collinear or not? There are several methods in order to determine it. And let's start with the first method. In the reference frame, we give the vectors u with coordinate x, y, and the vector v with coordinates x prime and y prime. So, in order to determine whether they are collinear or not, we have to calculate what is called the determinant. So, in this case, well, the determinant is equal to the cross product of the coordinates of both vectors. So, in this case, it is equal to x times y prime minus y times x prime. And, well, let's take an example in order to understand better. So, in this case, we're given two vectors, the vector u of coordinates 2, 1, and the vector v of coordinates -6, -3. So, in order to determine if they're collinear, let's calculate the determinant. So, the determinant will be equal to 2 times -3 minus 1 times -6. And we obtain that it is equal to 0. Thus, we can say that u and v are collinear. And now, let's hop into the second method. So, two vectors u and v are considered to be collinear if and only if the ratio of their corresponding coordinates is equal. So, in this case, we have the two vectors, of course, u of coordinates ux, uy, and v of coordinates vx, vy. So, what I just said is that the two vectors are collinear if and only if ux over vx is equal to uy over vy. And in order to show that, let's take an example. So we have here the two vectors as before. So vector u of coordinates 2, 1, and the vector v of coordinates -6, 3. Here, in that case, we have that ux over vx is equal to uy over vy, which is equal to -1/3. Hence, we can conclude that the vectors u and v are collinear. And finally, we have the third and last method. This method is especially useful when you don't have the coordinates of the various vectors. So, two vectors, u and v, are considered to be collinear if and only if it exists a scalar k pertaining to the real numbers such that u is equal to k times v. So let's take an example to better understand this method. So basically we have two vectorial equalities. So the first one, AB is equal to 2IG plus GL, and the second one, EF is equal to 4/3 EG plus 2/3 GL. So thus we can say that EF is equal to 4/3 IG times 2/3 GL. I just repeat what's given here, and from there we can factorize by 2/3, and we obtain that EF is equal to 2/3 times 2IG plus GL. And we actually recognize here that this expression is actually the expression of AB. So we can actually replace it by AB, and we have that EF is equal to 2/3 AB, which is equal to K times AB, with K equal to 2/3 in this case. So basically, we find this equality that we've written here at the beginning, and hence we can conclude that vectors EF and AB are collinear. And that's it. Thanks for watching. Leave us a like, hit that subscribe button, and always remember, be a wise guy. Give math a try.